6 months ago, Leila Morgan abandoned a product launch after one sentence in a customer interview changed the entire strategy. Today she opens an AI assistant and asks a dangerous question. Why did we stop? The answer returns with the old decision, the project it belonged to, and the next unresolved step. It feels like intelligence. But the model did not become wiser during the silence. Some system preserved, searched, or synthesized enough context to make the new conversation feel continuous. Across the room, auditor Jonah Reyes opens a paper ledger. He asks where the fact came from, whether it is still current, and what else the assistant may have carried forward. The next AI race is not only about which model can reason best, it is about which product can remember usefully without turning a helpful history into an invisible one. First, remove a common illusion. A model can use information inside the current conversation without keeping it for next week. That is working context, the notes already on the desk. Persistent memory is different. It writes something that can influence a later conversation, retrieves an older record, or rebuilds context from a project or connected source. Leila places 4 transparent panels in a row. The first holds this chat. The second holds a cross-chat synthesis. The third searches an archive. The fourth opens a project room full of files and instructions. They can produce similar answers while using different data paths and controls. Jonah labels each panel before anyone calls the whole wall memory. If we confuse immediate context with persistence, we cannot tell what was saved, what was searched, what can be deleted, or why an old detail returned. Leila is a documentary designer who manages overlapping clients, research threads, and launch decisions. Her coral field jacket carries a brass notebook clip. The notebook itself is full of arrows between ideas that only make sense months later. Jonah is an information auditor. His teal overshirt has a cyan badge, and his graphite ledger records source, date, scope, and deletion path. Leila wants continuity because rebuilding context wastes creative energy. Jonah wants boundaries because a remembered error can become a confident premise. They are not opposing characters. They are the two requirements of a useful memory system. Throughout this film, Leila will ask whether the assistant can pick up the work. Jonah will ask whether a person can inspect, correct, pause, delete, separate, and export what carried forward. A memory that serves only one of them is incomplete. The archive opens into 7 floors. Current chat context sits at the bottom. Above it, a product may synthesize useful facts from earlier chats. Another floor searches old conversations only when asked. A project floor groups chats, files, sources, and instructions. An instruction floor stores preferences the user supplied directly. A connected app floor retrieves context from services such as mail, documents, photos, or calendars when authorized. At the top, local activity history can summarize work across permitted apps and websites. No vendor implements every floor in the same way. Some write a compact memory. Some keep the source and search it. Some assemble context only inside a project. Some rely on another account's data. The visual result may be one smooth answer, but the governance problem changes at every floor. It remembers is the hook. Which layer, from where, under whose control? Is the documentary. OpenAI's current documentation draws a boundary that product demos can blur. ChatGPT on the web uses ChatGPT memory. Local Codex clients use a separate local memory store and separate controls. In the ChatGPT desktop app, a memories control can decide whether a chat uses local memories or contributes to future ones. ChatGPT work follows the settings available to the person in workspace. It does not quietly become the same thing as the local Codex store. Leila walks between a cloud-lit reading room and a cabinet on her own machine. Jonah ties a different label to each key. The official page does not establish universal plan, account, region, or workspace availability for every memory behavior, so our claim stays qualified. Where available, these are different platforms and different memory systems. One brand name does not make one storage model. The local Codex memory is unusually concrete. OpenAI says it can turn useful context from eligible prior chats into local files under the Codex home directory. It skips active or short-lived sessions, redacts secrets from generated fields, and updates in the background rather than instantly after every conversation. Generation can also be delayed or skipped. The feature is off by default and controlled through personalization settings or local configuration. Leila slides open a physical drawer and finds summaries, durable entries, and supporting evidence rather than a mystical portrait of herself. Jonah circles the important warning. Generated memory is a recall layer, not the only home for rules that must always apply. Secret redaction is a safety measure, not a promise that every sensitive detail will vanish. Local and inspectable still requires review. Next, Leila opens a project. The room contains related chats, uploaded files, connected sources, and project instructions. A new conversation can work with that shared context without pretending the model permanently learned every document. OpenAI's current project documentation also separates product surfaces. A ChatGPT project on the web group's project sources. A local project in the desktop app can connect to folders on the computer. The command line and IDE organize work through their current directory or workspace. Jonah places a door around the room. Project context is valuable partly because it is scoped. The launch brief belongs here, not in an unrelated medical question or family conversation. Calling the room memory may be convenient, but its actual strength is visible organization and retrieval. The source remains a source, and durable rules still belong in durable documentation. OpenAI's computer history pushes the boundary beyond chat. On supported Mac OS systems, allowed apps and websites can contribute interaction events. Clicks, typing, shortcuts, app switches, and text or context exposed through the operating system's accessibility layer. The system periodically turns those events into summaries and local memory files. OpenAI says it does not put screenshots, microphone input, system audio, or private mode browsing into that history. Leila crosses a studio where yesterday's work appears as a timeline, not a continuous screen recording. She can ask what she was doing before a break or where a recent document came from. Jonah checks the stronger use. The history should identify the source, then the assistant should read the source directly when the source is better evidence. A summary is a signpost, not a replacement for the underlying file. The availability matrix matters as much as the demo. The official page says computer history is off by default for ChatGPT Pro, Business, and Enterprise users in the ChatGPT desktop app on Mac OS. Pro users must opt in. Business and Enterprise administrators must first grant workspace access, and each member must still choose to turn it on. It requires memories, does not work through an API key or Amazon Bedrock, and is documented for supported regions including the European Economic Area, Switzerland, and the United Kingdom. Temporary event files remain on the Mac for up to 48 hours. Generated local memory files remain until the user deletes or clears them. Leila cannot carry this claim to Windows, mobile, every plan, or every workspace. Jonah closes each unsupported door. Availability is part of the fact. Google documents another path. Gemini apps can personalize responses using memory of past Gemini chats. A person can turn memory on or off, ask whether past chats influenced an answer, correct Gemini in the current chat, and delete old conversations from Gemini app's activity. Leila asks about a travel style she mentioned months earlier. The important visual is not the personalized answer. It is the trail back to the settings and old chat. Google's overview also says personalization can come from preferences and connected apps, which are separate mechanisms. Jonah places 3 pipes behind the same response: past chat memory, explicit instructions, and external context. If the product combines them, the user still needs to know which pipe supplied the detail. Personalization is the experience. Provenance is the control surface. Google's current help page surrounds past chat memory with hard conditions. The user must be 18 or older, signed into a personal Google account, and have keep activity turned on. The feature is not documented for work, school, or supervised accounts. Current surfaces include the Gemini mobile app, Gemini on the web, Gemini in Chrome where that product is available, and Gemini on a smartwatch. The page says the feature does not work inside some experiences, including gems and live chats. It also says personalization features are not available to everyone. Leila carries an eligibility card through 5 gates. Jonah refuses to shorten it to Gemini remembers. Plan, account type, platform, country, settings, age, and rollout can all change the answer. A feature claim without its boundary is a future correction waiting to happen. Now Leila deletes an outdated chat that said she preferred a deadline that no longer exists. Google warns there can be a short delay before Gemini stops using a deleted chat for personalization. If the same detail also came from a connected service, deleting the chat may not remove the source, and disconnecting the service may not remove the copy or inference already present in Gemini app's activity. The official control path can require both actions. Jonah turns the delete button into a sequence. Identify the source, remove the relevant chat or activity, disconnect or change the external source where necessary, wait for the documented update and test again. Good forgetting is not theatrical. It has post-conditions. The system should make clear which store changed, which did not, and when the old detail should stop returning. Google's personal intelligence documentation describes eligible users connecting services such as photos, YouTube, workspace apps, search services, and contacts. The assistant can use relevant material to personalize a response or perform a task. That is powerful, but it is not the same as a model storing an autobiographical memory of the whole account. The source system still has its own data, permissions, settings, retention, and deletion. Gemini app's activity has another. The page includes warnings about training and human review and tells users not to connect confidential sources they would not want handled under those terms. In our archive, Leila follows one travel fact from email to a Gemini interaction. Jonah makes both copies visible. The honest claim is retrieval from an authorized source for eligible users, not the AI remembers your entire inbox. Anthropic's Help Center separates 2 capabilities that feel similar in use. Search over past chats is documented for paid Pro, Max, Team, and Enterprise plans on the web, Claude Desktop, and Claude Mobile. A person can ask Claude to find an earlier conversation and can turn search and reference off. That is retrieval. The source conversation remains the object being found. Memory is a different path that synthesizes useful context for later work. Leila sends one request down both tracks. Search returns the old meeting. Memory supplies a compact summary of recurring work. Jonah keeps their evidence badges separate. One can quote a specific historical source. The other can influence the new conversation without replaying every chat. When a vendor offers both, the most important question is not whether the response felt familiar. It is which system produced the familiarity. Anthropic's current documentation says an improved memory experience is being introduced gradually. It is the default for new users, and users on free, Pro, and Max plans are being migrated. Team and Enterprise administrators are told to expect more rollout information. Those accounts remain on a legacy experience in the meantime. For the new experience, Claude synthesizes key insights from non-project chat history and updates that synthesis every 24 hours. Leila stands between 2 nearly identical doors with different mechanisms behind them. Jonah stamps the research freeze date across both. Claude memory is not one timeless claim when accounts can be on different rollout states. If a viewer cannot find a documented setting, that does not prove it was removed or that the viewer is mistaken. Their plan, workspace, and account migration may differ. In Anthropic's documented improved experience, each project has its own memory space and project summary, separate from other projects and from standalone conversation memory. Leila places a film archive beside a finance archive. Their color, characters, and deadlines cannot bleed together. The product can still search or summarize history, but the project boundary gives the context a location. Jonah tests the dangerous case, a confident detail from Project O appearing in Project B. Separation does not make mistakes impossible, and the official page does not publish an accuracy rate. It does, however, reveal the intended architecture. That makes project boundaries auditable. A user can ask which project should contain the fact, whether the summary updated, and whether deleting or moving the source changes the right space, rather than an invisible global profile. Anthropic documents controls with different consequences. Pausing memory keeps the existing memory, but stops it from being used and stops new conversations from being summarized into future memory. Reset permanently deletes the memories, including project memories, and starts from scratch if the feature is enabled again. Deleting a conversation removes it from memory synthesis, with the synthesis updated within 24 hours. Memory data is included in data exports, and organizational retention policies still apply. Leila reaches for one red lever. Jonah separates it into pause, reset, delete source, export, and wait. Their verbs matter. Pause is not deletion. Incognito is not necessarily outside organizational retention. Removing a chat is not an instantaneous rewrite. A trustworthy interface should make the action and expected result as distinct as these labels. Anthropic also documents memory import and export. At this research freeze, imports are available for free, Pro, Max, and Team plans on the web and Claude desktop. The help article says the updated memory can appear within 24 hours, and that Claude's memory is designed to focus on work-related topics, so imported personal detail may not survive. Leila carries a small archive case through a doorway. It is not her entire history, and no official source promises a lossless, universal format. But the door itself is strategically important. Portability has become a product feature. Jonah labels the stronger conclusion as inference. If useful context can leave, switching friction may fall. If it cannot, accumulated context may become a moat. The documentation proves the interface exists, not how much lock-in it prevents. Anthropic says incognito chats are available across free, Pro, Max, Team, and Enterprise plans. They are not saved to ordinary chat history, and are not used when searching previous conversations. That sounds like forgetting, but the same documentation adds an organizational qualifier. Team and Enterprise incognito chats can appear in standard exports and follow the organization's retention policies. Leila walks behind a frosted screen. Jonah can no longer find the chat in personal history, but an Enterprise archive remains visible in the background. Privacy words describe scopes, not absolutes. Not in history, not used for search, not synthesized into memory, not retained by an organization, and deleted everywhere are 5 different claims. The film uses only the claims the product documents and refuses to let a ghost icon carry more meaning than its policy. Step back from the brands. 3 architectures explain most of what we have seen. The first saves an explicit item, a preference, instruction, or memory. The second synthesizes many interactions into a smaller profile or project summary. The third retrieves source material at answer time by searching chats, files, apps, or activity history. Real products can combine all 3. Leila builds a memory answer from colored parts. Jonah asks what happens when they disagree. Does an explicit correction override an old synthesis? Does a fresh file defeat a stale remembered preference? Can the answer show which source won? Architecture becomes experience through conflict resolution. The most useful assistant is not the one that remembers the largest quantity. It is the one that assembles the right context for this task, while preserving enough provenance for a person to challenge the result. Every durable memory begins with a right decision. Which chats are eligible? Are active conversations skipped? Is the input a direct instruction, an automatic synthesis, a project summary, or an imported profile? Are secrets redacted? Does the user review the item before it influences future work? OpenAI documents background extraction controls for local Codex memories. Google ties past chat personalization to activity settings. Anthropic documents automatic synthesis and account rollout. Leila feeds the same sentence into 3 machines and receives 3 different records. Jonah treats the right path like a production pipeline. Input, extraction, filtering, scope, storage, audit. Errors introduced here can outlive the original conversation. A memory product should reveal enough of the right contract for a user to understand how a fleeting remark became durable context. Storage is only half the system. On every new task, something decides whether a memory is relevant, whether to search an old chat, whether to open a project source, and how much context to include. The wrong read can be as damaging as the wrong write. A preference from a personal conversation may not belong in a client workspace. A 6-month-old launch date may lose to the current brief. A project summary may be useful until the underlying file changes. Leila asks for a recommendation. Jonah makes the retrieval path visible behind the answer. The system should prefer current, scoped, inspectable sources when the stakes rise. It should state uncertainty when memories disagree. A confident sentence with hidden provenance is not continuity. It is an unaudited merge. Leila tells the assistant she no longer works on Fridays. Then the schedule changes. A useful memory product needs more than a place to store the first fact. It needs a correction loop. Inspect what the system believes. Correct the fact or source. Delete the old chat or activity where required. Update or disconnect the connected system if that is where the detail lies. Wait for any documented synthesis delay. Ask the same question again and verify the answer. Google explicitly documents correction in chat, activity deletion, and the possibility of a short delay. Anthropic documents a 24-hour synthesis cycle for changed or deleted conversations. Jonah measures success at the end, not at the click. Forgetting is complete only when the stale detail stops shaping the relevant response. Continuity is built from information that matters precisely because it is personal, operational, or sensitive. A local memory file can expose work patterns to other programs running as the same computer user. A connected app can supply excerpts from mail or documents under separate product terms. A workspace can impose retention and export rules. A past chat synthesis can carry a detail into a context where it no longer belongs. Official pages from OpenAI, Google, and Anthropic all devote space to controls because memory widens the privacy surface. Leila sees a convenient bridge. Jonah sees every identity, storage location, permission, human review path, and deletion system under it. The right response is not panic or blind trust. It is data minimization, scoped projects, explicit opt-in, sensitive source exclusion, regular review, and independent verification for consequential work. Persistent context also changes the lifetime of manipulation. A malicious page, misleading document, or accidental instruction can be summarized into a memory that appears later, after the original warning has disappeared. OpenAI's computer history documentation explicitly calls out prompt injection risk from content in apps and websites. The broader failure mode is an editorial inference. Untrusted input can become trusted-looking context if the right path loses provenance. In the lab, Leila finds a false instruction inside a project note. Jonah follows it through extraction, storage, and a future task. The defense is not one magic filter. It is source labeling, scope separation, untrusted content handling, human review correction, and a reset path. Memory should preserve why a fact was believed, not only the fact-shaped sentence. Model benchmarks change quickly. Accumulated context changes slowly. Months of projects, corrected preferences, work patterns, chat search, and connected sources can make an assistant feel uniquely useful even when another model is stronger on a test. That suggests a new competitive moat, not intelligence alone, but the cost of reconstructing the relationship. We have no measured switching rate study in this evidence packet, so Jonah stamps the claim, editorial inference. Anthropic's import and export controls show that vendors already treat memory movement as a product surface. Leila tries to carry her archive through a narrow doorway. Some parts fit, some become a summary, some stay behind in projects and source systems. The winner of the memory race may be the product that earns continuity without holding it hostage. Every official page describes useful workflows. Resume recent work, find an old conversation, use a project's shared files, personalize a response, or locate a document from activity history. Those are product capabilities, not independent evidence that memory increases output by a particular percentage. The sources in this film do not provide a causal productivity study, a universal accuracy rate, or a head-to-head memory benchmark. Leila wants to write saves hours. Jonah removes the number. They keep the measurable workflow instead. How many minutes did reconstruction take? How often did the retrieved fact match the current source? How many corrections persisted? And whether the user could leave with usable context. Honest documentary storytelling can still make a strong argument. It simply separates what the product does, what the vendor says it helps with, and what independent evidence has not yet established. Jonah turns the archive into an 8-question scorecard. Scope. What can be written from which chats, projects, apps, or activity? Inspect. Can the user see the memory or source? Correct. Can a bad inference be edited? Delete. Which store changes and on what timeline? Pause. Can future reads and writes stop without ambiguity? Separate. Are personal, project, workspace, and local context isolated? Export. Can useful context leave? Availability. Which plan, platform, account, region, workspace permission, beta, or rollout condition applies? Leila adds a 9th practice without adding a 9th score. Verify the current source before a consequential action. A product does not need to remember everything to score well. It needs to make the memory contract legible enough that continuity remains under human ownership. Leila returns to the abandoned launch. The assistant finds the right project, identifies the old interview, and surfaces the decision with a date. Then it opens the current brief and notices that the customer segment changed. Instead of repeating the old recommendation, it explains the conflict and asks which strategy should govern the next draft. Jonah checks the source ledger. Right project, right interview, current file, uncertainty visible, no external action taken, owner decision still pending. The impressive moment is not that the AI remembered a sentence from 6 months ago. It is that the system treated memory as evidence rather than authority. Continuity helped the work move faster, and fresh context prevented continuity from becoming inertia. The race to give AI a memory is real, but the finish line is not total recall. Products are building cross-chat synthesis, project spaces, search, explicit instructions, connected app context, local history, and import or export. Each layer can reduce repeated setup. Each can also preserve an error, expose a sensitive detail, cross the wrong boundary, or create friction when the user wants to leave. Leila locks the useful records inside labeled project rooms. Jonah leaves the correction and export doors open. The most valuable assistant may not be the one with the highest benchmark or the longest history. It may be the one that remembers the right context, shows where it came from, forgets on command, and lets the relationship travel. Intelligence answers the question. Governed memory decides whether the answer still belongs to you.